we're going to look at section 5.4. In this section, we're going to continue looking at our trig identities for the sum and difference of two angles. First thing we're going to look at is the sine of A plus B. When I look at the sine of A plus B, I'm going to get the sine of A cosine of B, same connection value, plus cosine of A sine of B. Now when we look at this, I like to think of these formulas together. What if instead of A plus B, what if I had A minus B? I'm going to have the same similar terms over here, but I'm going to connect them with the subtraction symbol. So whatever the connecting operation is here, that's the connecting operation over here. Similarly, I have a formula for tangent of A plus B, and I can also use a similar formula for A minus B. On the right-hand side, the numerator is going to be tangent of A plus B plus tangent of B. If I added here, I would add over here. My denominator is going to be 1. It's going to be the different symbol. So if I'm adding here, I would subtract here. Tangent of A times tangent of B. If I have a subtraction symbol here, then in my numerator, it's the same symbol, and in my denominator, it's the opposite symbol. So we have these formulas that we're going to use for the sum and difference for sine and tangent. So one of the things we can do with this formula, suppose we are asked to find an exact value for the tangent of 13 pi over 2. Calculator is not going to give me an exact value. I need to find two angles that when I add them or subtract them will give me a result of 13 pi over 12. So when I look at this, I think of the angles that I already know values for. 0, pi over 3, pi over 4, pi over 2, pi over 6. And I notice that a denominator of 3 and a denominator of 4, if I work with those to find a common denominator so that I could add or subtract them, I would end up with denominators of 12. So after thinking of some possibilities, I am easily able to see that 4 pi over 3 and pi over 4 will be the values that I need. To get a denominator of 12, I multiply 3 by 4, so 4 pi would become 16 pi. To get a denominator of 12, I multiply 4 by 3, 3 times pi is 3 pi. And to get 13 pi, I would need to subtract those. So to find the tangent of 13 pi over 12, I need to find the tangent of 4 pi over 3 minus pi over 4. So in order to look at that, I now just need to apply my formula. This is the tangent of 4 pi over 3, same connection symbol, minus the tangent of pi over 4. My denominator is going to be 1, and then I'm going to use the opposite connector, so that's going to be plus, and I'm going to have tangent of 4 pi over 3 times tangent of pi over 4. So now all of these angles are angles that I know the exact values for. Tangent of 4 pi over 3 is the square root of 3. The reference angle is pi over 3, and 4 pi over 3 is in quadrant 3, so that value would be positive. Tangent of pi over 4 is 1, and pi over 4 is in quadrant 1. Divide that by 1 plus the square root of 3 times tangent of pi over 4 is 1. So to simplify that, I've got the square root of 3 minus 1 over 1 plus the square root of 3. Now when I look at that, I have a radical in the denominator. I need to get rid of my radical. So we have to go back to what we learned in algebra, and we have to rationalize this by multiplying by the conjugate. The conjugate takes the same two terms and changes the connecting symbol. So I'm going to multiply by 1 plus the square root of 3. That would be 1 minus the square root of 3. I change the connector. So when I multiply in the numerator, I'm going to have to distribute term to term. So square root of 3 times 1 is the square root of 3. Square root of 3 times the square root of 3 is 3, and that's going to be connected with the negative symbol. Now I distribute the negative 1. Negative 1 times negative 1 is negative 1. Negative 1 times negative square root of 3 is plus the square root of 3. In my denominator, 1 times 1 is 1. 1 times negative square root of 3 is negative square root of 3. Positive square root of 3 times 1 is positive square root of 3. Positive square root of 3 times negative square root of 3 is negative square root of 3 squared, which is 3. So when I simplify these terms, I've got square root of 3 plus square root of 3, which is 2 square roots of 3. Negative 3 minus 1 is a negative 4. Over, notice here, the square root of 3's cancel, and I have 1 minus 3, which is negative 2. Now, I have to be careful here. I can only cancel factors that are common in both of them. So what I usually tell students is, if you cannot factor it out of everything in the numerator, then you can't cancel it. Since my denominator is a negative 2, I'm going to factor out a negative 2. So I'm going to have negative 2 times negative square root of 3 plus 2 over negative 2. The negatives 2 cancel, and I've got negative square root of 3 plus 2, which you could also write as 2 minus the square root of 3. So it took us a little bit longer than using a calculator, but we were able to find the exact value for tangent of 13 pi over 12. It's 2 minus the square root of 3. Now, another type of problem we might be asked to do is we might be asked to find the sine of s plus t and the quadrant that s plus t lives in. Now, in order to do that, we're going to be told in this problem that the sine of s is equal to 2/3 and the sine of t is equal to negative 1/3. S is in quadrant 2 and t is in quadrant 4. Now, one of the tricky items here is, in order to find the sine of s plus t, I have to know the sine of s and the cosine of s, and the sine of t and the cosine of t. So when I look at these, I have the sine values, and I know the quadrant of my angles. In order to find the cosine value for sine of s, I have to go back and use the identity sine squared of s plus cosine squared of s is going to equal to 1. Sine of s is 2/3, so sine squared of s is going to be 4/9. So in order to solve this for cosine squared s, I need to subtract 4/9 from both sides. So I'm going to think of my 1 as being 9/9. Cosine squared of s is then going to be 5/9, and cosine of s is going to be the square root of 5 over 3. Now, when I take the square root, I have to remember to take plus or minus. So cosine of s could be square root of 5 over 3, and it could be negative square root of 5 over 3. But remember, I was told that s was in quadrant 2. In quadrant 2, cosine is negative. So cosine of s is going to be negative square root of 5 over 3. So I found cosine of s, but I still need to find cosine of t. So I'm going to do the same thing. Sine squared t plus cosine squared t is equal to 1. Sine of t was negative 1/3, so sine squared of t is going to be 1/9 plus cosine squared of t. And again, I'm going to think of 1 as being 9 over 9 so that my subtraction becomes easier. So cosine squared of t is going to be 8/9. I take the square root of both sides. Cosine of t is going to be plus or minus. Square root of 9 is 3. Taking the square root of 8, 8 has a factor of 4. That's a perfect square. The square root of 4 is 2, and I'm left with a square root of 2 under the radical. So again, I know the positive or negative values, but how am I going to find the exact value of cosine of t? Look back up here. T is in quadrant 4. In quadrant 4, cosine is positive, so cosine of t is going to be 2 square roots of 2 over 3. Now that I have all of those values, I know that the sine of s plus t is equal to sine of s cosine of t plus cosine of s sine of t. Sine of the first angle, cosine of the second angle, same arithmetic symbol, cosine of the first angle, sine of the second angle. So now I've done all of the previous work. I just need to plug in some values. Sine of s was given to me as 2/3. Cosine of t we calculated as 2 square roots of 2 over 3 plus cosine of s we found was negative square root of 5 over 3, and sine of s we were told was negative 1/3. So now we just do some arithmetic. I end up with 4 square roots of 2 over 9. Here I have a negative times a negative, so that's going to be positive square root of 5 over 9. So I add this, I get 4 square roots of 2 plus the square root of 5 over 9. Now I have a value for the sine of s plus t, but I was also asked where is s plus t? Well, if I look at s plus t, I know that the sine value, sine of s plus t, is greater than 0. The problem is sine is positive in quadrant 1 and in quadrant 2. So knowing that the sine is positive, I know that I'm either in quadrant 1 or quadrant 2. The only way to determine if I'm in quadrant 1 or quadrant 2 is to also find the cosine of s plus t. The good news is I already have all of the values that I need for that. Cosine of s plus t is cosine of s cosine of t. When I use the cosine formula, I take the opposite value. So instead of adding, I'm going to subtract sine of s sine of t. So I already have these values. Cosine of s, we saw before, was negative square root of 5 over 3.